Special functions. We're going to talk about a couple special functions today. The first one is what we call a step function. It's a graph which is a series of line segments. All right? Because each part is linear, this type of function is what we call a piecewise linear function. Piecewise meaning it's pieces. It's not like just a linear function like this. All right? Instead, it's going to look like this. It looks like steps. All right? One example of a step function is the greatest integer function. Yeah, you should be writing this. Written as f of x equals, okay, and we call it the double bracket sign. That just means greatest integer function. That's where f of x is the greatest integer, not greater than x. We're going to talk about it. So inside the double brackets, you look at what x is. All right. What we want is the greatest integer, not greater than x. So if you look, the double bracket signs are on 6.8. Okay. Integers are like whole numbers. Okay. But with negatives, so -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Those are all integers, right? Integers do not have fractions. They don't have decimals. So the greatest integer of 6.8 would be 6. Okay, it's not 7 because we can't go greater than 6.8, right? Right? It's not greater than x.
So it'd be whole numbers?
So it's whole numbers. Yes, whole numbers and negative numbers, not like integers. Okay.
How come, supposed to be hard? How come you run
It will
down
be.
on the first one, but
Okay.
That's a negative.
It's a negative.
It's negative. Okay. Negative 2.5. What's the greatest integer? Okay. Not greater than negative 2.5. Well, if I went negative 2, isn't that greater than negative 2.5?
Yeah.
Yes.
Yes, so I can't do that. So what's the greatest integer up to negative 2.5? Negative 3. All right? So now, everybody have this written down? No. Okay, please get this. So this is our parent function. Okay, I want you to write this down. I'll pass out graph papers. So that's how this is graphed. Okay, the closed circle means it's included. The open circle means it's not included. So if I was to pick 1 for x, what's the greatest integer of 1? 1. All right, and as you can see, okay, when I pick 1 for x, what's my y? 1. So it includes it here. All right, but everything up to 1, 1.9, 1.99, 1.999, what's the y coordinate of that? Or 0.9, 0.999? 0, right? So that's why everything up to 1 is 0 on the y. All right? So this is just a step function. All right? Now, like I said, let's look at negative 2.5 for my x. What would my y be? Remember, what was my greatest integer of negative 2.5?
3.
Negative 3, right? Well, look. Okay, what's my x is negative 2.5. It's right here, right? Okay, so what's my y coordinate? Negative 3, remember? Okay, because what's the greatest integer of negative 2.5? 3, negative 3. Okay, see how negative 2 is not included? Okay, negative 2 would give you a y of negative 2. So, let's talk about, I forgot, what's the domain of this function if it continues on in both directions? Okay, my x coordinate, remember domain is x coordinates. Okay, my x coordinates include what? Is there a limit to my x's? No. So my domain is all real numbers. Okay, all real numbers, because I could have any x coordinate in there, right? Could 9 be included in this function? Yes. Could 9.9? Yes. So all real numbers.
Until the
Okay? Any x domain's x coordinates, right?
What's the question?
It's what's the domain of this. Okay?
And we know that
Because if you look, it continues going in both directions. It includes every x coordinate on there, doesn't it?
So that's why.
Yes. So that's why it's all real numbers. My range, what's included in my range?
All real numbers.
No.
No real numbers.
Because is 1.5 included?
No. Oh, fake.
No, it's not. 1.5, is that included?
No.
No, what's the only thing included for y's?
2 over 1.
Not whole numbers. What's the other? It's integers.
Integers.
Remember, this is the greatest integer function?
Yeah.
So my range is all integers.
You said whole numbers the same thing.
No, because whole numbers are 1, 2, 3, 4, and 5.
Integers
Yeah.
are negative.
Integers are negative. 1, 2, 3, and 1, 2, 3, 4, 5. All right. So my range is all integers. All right.
I can't see you.
So then move. I want you to write this down. This is the greatest integer function of x plus 2. Okay? So if my x is 0, what's 0 plus 2? 2. What's the greatest integer of 2?
2.
So let's graph that. If my x is 0, what's my y coordinate? Okay, is this a closed dot or open dot? Closed because it includes it, right? What if my x is 0.5? What's 0.5 plus 2? What's 0.5 plus 2?
2.05.
How about 2.5?
That's not right.
Yeah. What is the greatest integer of 2.5 not greater than 2.5? It is 2. So everything up to what is going to be included?
2.
Up to 1, right?
1.
Because what is 1 plus 2?
3.
3. What's the greatest integer of 3?
3.
3. So is 1 on my x. What's my y coordinate at 1 for my x? What's my y coordinate? 3. Okay, and it's a closed circle, right? Because it includes the 1, 3, right? So up to here is going to be an open circle. Up to 1, so 0.9999, okay? What's the y coordinate of 0.999?
0.
About 2.
What?
Shane, just hush.
So confusing.
Yeah, that's why. 1.25. What is 1.25 plus 2?
3.25.
What's the greatest integer of 3.25 not greater than 3.25? 3. Okay, what about 2? What's 2 plus 2? 4. What's the greatest integer of 4? Okay, so 4, at 2, 4, it's included. It's a closed circle. So up to the 2 is an open circle. What about 2.75 plus 2?
4.75.
What's the greatest integer of 4.75 not greater than 4.75? 4. What if I put 3 in there?
That'd be 5.
3 to 5, what's the greatest integer of 5? 5. Okay, so if you see a pattern here, this is a step function like this, right?
That was like a wire linear function.
Okay, if I put negative, let's go with negative 1. Now what's negative 1? What's negative 1 plus 2? 1. What's the greatest integer of 1? So at negative 1, okay, it's going to be a closed circle around 1, right? So open circle around 0. So do I have to keep filling out a table, or could I just graph it? Once you figure out the first couple points, okay, then you know all of them. Okay, now I'm not going to make you do the entire graph, okay, but do most of it. Okay, what would be our domain here? What is my x coordinates? Hush. What's my x coordinates? Is my x coordinates limited to anything?
No.
No, so we say the domain is all real numbers. Well, what's my range? What's my range limited to?
All whole numbers.
Not all whole numbers, all integers. Write this down. What's the absolute value of negative 7? What's the absolute value of 7? 7. So that's that's what we call absolute value. Absolute value is the distance a number is from 0. Alright, we just get rid of the negative sign. That's all you're doing. Alright, this is described as x if x is greater than 0. It's 0 if x is 0. F of x equals negative x if x is less than 0, meaning it's a negative number. Okay, and this would just be what it's graph like. So what's our domain? What's included in our x coordinates? Is it limited to anything? No, it includes all x's, right? It goes in this direction, it goes in this direction. So we say it's all real numbers. I'm just telling you right now, all domains usually going to be all real numbers. What's my range limited to? No, this is not. This is absolute value function. It's not the same. No, because does this function include negative 1, negative 2, negative 3? No. All right. It's y is greater than or equal to 0. Y can be any number greater than or equal to 0. Does this keep on going up? Yes. So would it include 11, 12, 13? Would it include 100? Yes. Okay. But it doesn't include negative 1, negative 2, negative 3. So technically you could say it's all whole numbers. But we just describe it as y is greater than or equal to 0. Okay. Because 0 is my smallest y. Absolute value of x minus 4. I'm just going to pick some points here. I'm going to pick 4 for x. I'm going to always pick 0. I'm going to pick 8. And I'm going to go 10. I just picked 3 or 4 points. Okay? This is going to give me an idea of what this function looks like. So, if I put in 4 for x, what is 4 minus 4? 0. What's the absolute value of 0? 0. So I write this point out. 4, 0. It's right there. Okay. 0. What's 0 minus 4? Negative 4. What's the absolute value of negative 4? 4. So I write my coordinate 0, 4. I pick 8. What's 8 minus 4? What's the absolute value of 4? So I go to 8, 4. I go 10 minus 4. What's 10 minus 4? 6. What's the absolute value of 6? So I go to 10, 6. Does this give me an idea what my graph looks like?
Absolutely.
Thank you for your enthusiasm. Okay, this is what the graph looks like. Okay, I probably should have picked a couple other points, but not necessary. What you have to do is you have to find where it hits 0. Okay, where the point is at it. All right, I knew that my y would be 0 if I plugged in 4 for x, because 4 minus 4 is 0, right? So that made my graph look like this. What's my domain? All real numbers. Andrew, what's my range? What's my smallest y coordinate here? On this line, what's my smallest y? 0, right? Right here. Okay. Right here. So that would be 0. So y is greater than or equal to what? 0. Okay. Any questions on how to do absolute value? Draw this. This is what we call a piecewise defined function. So write all of this down. Also want to make a table of x and y. Okay? And I look up here. It says it's negative 2x if x is greater than 1. And it said that it's this function if x is plus 3 if x is less than or equal to 1. So I want 1 as my x. Also want 1 bigger than 1, 2. Also want an x coordinate that is smaller than 1. So I'm going to pick 0. We call this a piecewise function because it's two separate functions. Okay? You have negative 2x and you have x plus 3. You have to decide which one you're going to use depending on the criteria. Criteria as in x is greater than 1 or x is less than or equal to 1. That criteria tells you which graph to use, which function to use. So if I pick 1, which one do I use? Negative 2x or do I use x plus 3? I use x plus 3 because this is x is greater than or equal to 1, right? So what's 1 plus 3? 4. So I need the graph 1, 4. And I need a closed circle because it includes... No, sorry. It needs to be 1, 4. Because it includes 1, right? So it needs to be a closed circle. So if I picked 2, which one of these do I use? Negative 2x or x plus 3? If I pick 2 for my x. I use negative 2x because this says that x is greater than 2. I use this one. Is 2 greater than 1?
Of course.
Yes, 2 is greater than 1, so I use this function. Okay? So it would give you negative 4, right? 2 times negative 2. So I go 2, negative 4. Okay? That's going to be a point. If I put 0, which one do I use? Nick says x plus 3. He's right because 0 is less than or equal to 1. So what's 0 plus 3, Nick? 3. So I need to go 0, 3. Okay. My graph is going to go in this direction. This way, agree? X plus 3 is going to go in that direction. If my x is less than or equal to 1. For my graph of negative 2x, it's going to go in this direction, okay? But I need to go on to 1 because it's going to be an open circle around that. It's going to be open circle around 1, so it's going to be, right about there. So that's an open circle, and it's going to go in that direction, right? So this is what a piecewise function looks like. Because if I put 1.1 in for x, okay, which one do I do? Negative 2x or x plus 3? Negative 2x because 1.1 is bigger than 1, right? Well, what's negative 2 times 1.1? Negative 2.2. So it's going to be pretty close to negative 2, right, as my y? Yeah. Okay, so that's why it's an open circle around 1 because it doesn't include it. Because I could get closer to 1, I just can't be 1. So this is what it looks like. This is a piecewise function. All right? Any questions? Okay. Tomorrow I will have you write this down, and then you'll get your assignment. It will be due at the end of the hour tomorrow. Okay? I was hoping to give it to you today, but we'll do it end of the hour tomorrow.